Alright guys, this is a quick tutorial on how to install a tachometer on a DIY Go Kart. Let's dive right into it. So the main idea here is to use a Hall effect sensor and mount that using either this hole or make a cutout over here and then use that. In there we have a flywheel with a magnet which will help us determine the RPM of the engine. So after that very informative description, the next thing is about our processor for the nerds. We're going to be using the Arduino Mega because I need more pins on my Go Kart, but you could use the Arduino Uno. And there's all the stats for it if you want to read it. That's our Hall effect sensor. That's what's going to be collecting the pulses from the magnet. And this is a quick view on if you guys ever wonder how people know all this information about sensors that they buy. This is how you find it. Search up the name, get a data sheet, has all the information you need. Alright guys, so the setup here is we're going to plug into the Arduino and do a quick test of the sensor. And based on the data sheet, this should be our negative line. And if you guys have bought this sensor, I'm very sorry about the lighting, but there's a small minus symbol on that side. That should be the negative. The middle is a supply or power. The last one is our signal pin. The way we're going to wire this is ground to Arduino ground and power to the 5-volt rail. And our signal pin is for the digital 2 pin. So I just have this little piece of code to test out our sensor and collect what kind of input or output we're getting. And, let me go ahead and flash that. Okay, so the sensor seems to be reporting true when it's not getting a magnetic signal. So here we have the sensor. Oh, there we go. Oh, okay. So it only detects a magnet when it is directly in front of it, not on top or on bottom. So we'd have to mount it to the flywheel in a vertical position. Alright, so this portion is going to be me explaining the code. First we're going to start with the hashtag define tag pin 2. And this is us declaring the input pin on the Arduino. And the hashtag define, for those who don't know, is a more memory efficient way of defining that. That's for programs that are memory constricted, which I doubt it's going to be, but it's just a good practice to do that. So the unsigned long and the unsigned long over here for current millis and previous time is our setup for our timer. And the reason why we're using millis, if you don't know, delay causes the processor to literally stop and not do anything, while millis allows us to keep the processor running and a timer running at the same time. And if you want to learn more in depth, there's a lot of YouTube videos. You could go watch that about millis. So my delay is we're declaring a delay timer, as in how many seconds you want to pass as you count the pulse. Cars can do it in, I think, 500 milliseconds, or even shorter for more accurate RPM readings. But 1000 seems to be the most stable and efficient way of doing it. And that's 1000 milliseconds. So that's 1 second, and we're collecting how many pulses in that 1 second. So our RPM and our volatile unsigned pulse count. Our pulse count is a volatile variable because it's inside of an ISR. And our RPM is just our RPM. So with our setup, we initiate serial communication and pin mode. Attach interrupt, that's us declaring the interrupt. And the previous time, set it to millis. That kind of initiates the variable to start at 0. So our current millis equals millis. That gets the current millis running and being able to use the millis timer. Over here, we are checking if 1 second has passed. And if this 1 second is not passed within that 1 second, here's what we're going to do. we're gonna have this interrupt statement running, and every time the tachometer or tach sensor detects a pulse from a magnet, it's gonna increment and cause an interrupt with the processor to increment this variable. Once this variable has been incremented, it gets multiplied by 60 and we get our RPM. Well, the reason why we're multiplying by 60 is to convert the RPM collected in seconds into minutes, which is RPS into RPM. And then we're printing our RPM over here. At the end, we have to reset our pulse count after the 1 second has passed to start another reading. And we have to put previous time equals to current time in order to redo this calculation. So here's our setup. We have our code and all running on our laptop here. We're gonna get our output RPM hopefully. And here's the Arduino with the sensor all wired up. We have a drill over here with a little magnet and some electrical tape. Now the drill is rated at 1650 RPM on the lowest gear, or the highest gear. But I doubt the final drive over here is gonna read that. So as long as we get something close to 1000 RPM, I'm guessing the math is working. All right, here we go. That doesn't look good. I don't know why we're getting negative numbers here. Alright guys, so I found the problem. I did two things to fix it. First, the interrupt service routine variable was not declared as a volatile variable, and I made it an unsigned log to avoid the overflows in the memory. And that should fix the negative signs, but for right now, integer goes up to 36,000, so that wasn't the actual problem. The actual problem was here where I would set to low, and the pin would trigger too many times in a second if it was low on a continuous state, if that makes sense. So I made it falling, and falling seems to be working right now. So here's the test. So I'm on like a quarter speed right now. That's looking good. Like halfway up. And full speed. Alright, the problem with the zeros is the magnet is good, but this sensor is practically very bad. It's not able to pick up the magnet even though it's right next to it. So let me try that again. There we go. Look at that, we got up to rated RPM speed, 1650, boom. So guys, off camera, I finished mounting the LCD screen. It's a pretty crusty cut because I did it with an angle grinder. The rest were done by a water jet in my school, but I can't really use that right now. And I mean, it's mostly held down by hot glue on both sides. I might put some duct tape in the back. But yeah, it's pretty sturdy. I mean, it's not going nowhere. As for me, it matches my Go Kart's aesthetic, like a DIY high school looking project, which it is, if you guys can notice. But yeah, I recommend you guys try out whatever you want. This video is just to show you how to collect the data. How you want to display with an analog gauge and all that, that's your choice. So have fun with that. My 3D printed tolerances are pretty bad, so I'm gonna have to tap this in with the drill. So just make a note of that. When you guys print this, you might have to tap it. So something I didn't watch out for is the angle is gonna angle the screw, but I can't really make an angled hole right now, so I'm gonna try and bolt this in and just kind of leave it like that. That seems like an okay enough orientation for the sensor to reach the magnet. If not, I might have to make an angled hole. Alright guys, turns out this mount was absolute crap. The dimensions weren't correct, the tolerances weren't correct. I think the angle messed up most of that. And this kept hitting the flywheel. But we're gonna go back to the drawing board, make a different type of mount, and come back. Alright guys, here's the new sensor mount. This one is way more solid and should give us a better contact. So the way this is fit on there right now, it's a pretty snug fit by itself. And then as a reinforcement, I added some hot glue and then pressed the sensor into there and then hot glued the sides around. And yeah, it's a pretty solid mount. So make sure you do solder the wires before you install it, and make sure you've left yourself enough length to wherever your microcontroller is. In my case, it would be from here to somewhere around there. So I'm not going to cut my wires, I'm actually going to leave it in the spool itself. And don't worry, all the files for the CAD files and the code files are all going to be in the description or my GitHub. Guys, so we have the sensor all installed. This is the new bracket. Okay, so here's what we did. We used the original Arduino wires because I don't have a thin enough soldering tip and my hands are not still enough to solder these points to individual wires. And if you were to accidentally make any form of connection between these pins, you're not going to get accurate readings or just no readings at all. So I used these Arduino wires, and then I had these trail off, and then I soldered the male ends to my spools of wire here. And those spools of wire, I left them because I don't really know what length. I'd rather just be safe and not cut that right now and just take it up there and then cut it if you want to play it safe. So I hot glued the connections to make it more secure. And you want to hot glue this side and keep tension on the wires so these don't get caught up in the flywheel when you're spinning. And yeah, let's test fit this. Alright guys, so we have the Go Kart up on our amazing test bench of 2 blocks of stone. So off camera I didn't do much. All you see there, that wiring mess, is just me wiring up the Arduino to the LCD display. And I'll just link a YouTube video that will show you it way better than I could over here with this mess. But yeah, so we have the sensor over there connected, and then the LCD display connected. And the rest of the wires is for the other stuff I've hooked up. I just have headlights on. But yeah, don't mind that. And also, if you guys are going to be using the lead acid battery that I have, it might be a bad idea. You could just cop this $20 power bank, because the voltage converter in the Arduino is very inefficient. It gets the Arduino very hot, and it's just a waste of power. So just get this cell phone charger bank, and it will do a much better job. So let me go and hook that up to power. Alright, so that's hooked up. The 12-volt battery is not doing anything over here right now. It's for headlights only. So we do have power over here, as you can see. Let me get the phone off. We have the RPM reading 0. And don't worry, all the code is going to be in the description. You guys literally just have to plug, copy, and paste, and you should be on your way. And I'll play the video when I start up the engine.